A quick look at working with binomials and negative binomials. Well, first we're going to look at a binomial problem. So let's look at how the question would be posed. You have a 10-question multiple choice quiz. You didn't study. Each question has 4 answer choices. Therefore, you have a 25% chance of guessing correctly and getting the question correct. So answering it correctly. So the probability of a success is 0.25, 1 in 4. You have a 1 in 4 chance if you literally just wrote a letter down, totally guessed. So we're going to have our, first of all, we can look, is this a binomial? Do we have a set number of trials? Yes, we do. N is 10. So there's a set number of trials, in this case questions. Is the probability of a success the same for each question? Yeah. The probability of a success is 0.25 because each of the question choices have 4 answer choices and one of them has to be correct. So you have a 1 in 4 chance of getting it correct if you literally just randomly chose A, B, C, or D. Are each trial, each problem independent? Yes, we're going to assume that each question is different and doesn't rely on the other one. And with the idea of the probability of success, either you succeed or you fail. There's only 2 things that can happen, a success or failure. And we even found the probability of the success, and it was the same for each trial. So it meets the 4 criteria for a binomial. So my N is 10, my P is 0.25. So now I can ask questions with the binomial. So if we wanted to determine the probability of getting exactly 6. Out of the 10 questions correct, the probability x equals 6, and then round to 4 decimal places, I would call my variable x1 because it's, the first question that I'm asking. And I'd use the binom, the D binomial, where I have, here's my x value is 6. I have 10. I could put 10 in there, or since I already have N and P in there, I literally could actually, since I'm doing all of these the same, I could put N, since N equals 10, and my P, which is 0.25. You could actually keep putting them in for each time that you do this, or you could actually put the numbers in whatever you'd want to do. And then you say, let's look at X1, but we want to round it to 4 decimal places. Just looking at this clearly, determine the probability x equals 6. That's the probability that you get 6 out of the 10 questions correct. Then round. We're going to round to 4 decimal places. So we see that our probability is 0.01622, and rounded to 4 decimal places is 0.0162. Now let's think. So that's like about getting a 60 on the test. So now let's see if we want to say what would be the probability that I C or more. So greater than a C or more. So let's see the probability of 7 or more. So let's look at this question. So I want to find the probability x is greater than or equal to 70 because I want to C or better. Okay. Now let's think about what's going to happen here. Let's say that this was 7. This is the bar for 7, the bar for 8, the bar for 9, and the bar for 10. Okay. So we want to look for 7, 8, 9, and 10. But when we use the probability density function straight on, that would mean that it would take the probability of everything less than this. But we can do, say, lower tail false, meaning we want to see the upper tail. But let's look at what the lower tail would be. It'd be everything 6 or less. 6, 5, 4, everything less. So we'd say, here's the lower tail, the probability of the lower tail, whatever it would be. If I say I want the probability density function, but I want the lower tail to be false, so I'd have to say the probability x is less than or equal to 6 because I want to make this false. I don't want this. I want everything greater than it. So I could use the probability density function for the binomial, and I could say I want this to be 6, the N, and the P, which is 10 and 0.25, and just say lower tail equaling false. And we know these all have to be in caps when we do that. So that's one way I could find this probability. If I want x greater than or equal to 7, I could do P binomial 6 with our n and our p and making the lower tail being false. We can look at what it is and then round to 4 decimal places. And we'd get our probability. It's 0.0035. So getting a C or better when we totally guess. Pretty improbable. Now there's another way that we could do this also. We could have just said 1 minus p binomial 6np and not worry about the lower tail being false in here and get the same exact number that we got using the command that we did. It's just 2 different ways to get to the same answer. Both are correct. So now we want to find the probability that x is between 4 and 8, that we get between 4 and 8 correct, including 4 and 8. So in other words, we want to know this probability, that one, this one, and 8. We don't want anything greater than 9 or anything less than 3. So what we can do is we can say the probability of everything less than 8 and then subtract off the probability of everything less than 3 successes, and that would give us everything in there. So we want to have 8, everything 8 and less, but it's too much probability by 3, 2, 1, and 0 being correct. So we have to subtract those off. So I could do the code for that. So it would look something like this. Determine the probability between 4 and 8 questions being correct, including 4 and 8, to 4 decimal places. So the probability of everything less than 8, subtract off everything less than 3. We want to see 4, the probability of 4, so we subtract off all the probability of 3, 2, 1, or 0. There's, we can see our x4, and then we round to the 4 decimal places. Whoops. Oh, because I'm sorry, I should have put a P there. I don't know why the 9 was in there. So let me redo. So we can go on and just kind of redo this. Because that's got to be, it doesn't understand that probabilities have to be numbers between 0 and 1 and not greater than 1. So it should have been a P. Did a little too quickly. So we can see what our x4 is. And then now we can round to 4 decimal places. And hit enter, and there is our probability between 4 and 8, including 4 and including 8. And of course, if we wanted to know the probability of less than, let's just do less than 4. So if we wanted to find the probability x is less than 4, strictly less than 4, in here, then we would say, let's let our x5 equal, which is that less than line in there, and we just do p binomial. And now think about it. Would I do 3? Would my x be 3? Now remember, I want everything less than 4, not including 4. So I want to see 3, 2, 1, and 0. So when I do my p binomial, I want to see 3, comma my n, comma my p. Then I can print x5, or I can just quickly go on and round x5 to digits equal 4 decimal places. And we already see what x5 is. This is just looking at what it would be, and it would be 0.7759. So that's how you would get probabilities of strictly less than. And all of these were the binomial. Now let's look at what we would do with the negative binomial. So now we're going to keep with this idea of having a multiple choice question or test. So we're still in multiple choice, where each question has 4, has 4 choices. Okay, so the probability of choosing the right one is still 0.25. But we changed the way in which we ask the question. So we're going to find the probability x equal 14. We're going to use the DN binomial to find that answer. So we're trying to find that probability that 14 questions are incorrect and 6 are correct. So we do the, let's call it x8. Let's clear all this. Oh no, we're going to keep x8. and we're going to have that be the D negative binomial. If you want to see what the negative binomial does, you can always click onto here and see how it says press F1. If you press that, it will give you everything that the negative binomial and what all the code would mean. So this negative n binomial, in for my x, I'm going to put the number of incorrect answers. So we're looking at 14. The number of correct, or probability of a success, we said 6. And our probability of success is 0.25. Hit enter, and now I can say I want to see round x 8 digits equal 4. So now we have the probability of getting 6 correct and 14 incorrect. So a total of 20 questions on the test to get 6 of those correct is 0.0506. Now let's look at a different type problem. Still negative binomial, but a different question. So we want to find out the probability of having more than 10 problems on the test before somebody passes, before they get 6 correct. Again, let's think about what happened. We want to find the probability of more than 10 problems on the complete test. So that's our n, is greater than 10. That is n equal 11 before 6 are correct. So again, let's look at number of questions on test. 11, 12, 13, 14, on and on, infinity. So here's the number that are wrong. Here's the number that are right, correct, R-I-G-H-T. We know this is always 6. So the number of 6 all the way out. This one is the one that's going to change. This is 5, 6, 7, 8, 9, 10, and on and on and on. So that each of these together will add up to give me the number total on the questions. So I can't find it straight up. I have to use the complement. But what's the complement? The complement is everything above this. So if this is 11, 5, and 6, its complement is going to be 10, which would make this 4 and 6. 9, 3 and 6, 8, 2 and 6, 7, 1 and 6, 6 questions altogether, 0 and 6, because that's the only way you could get 6 correct is have 0 wrong. So this is the complement of this right here. So how, if I do 1 minus this complement, I'll get what I'm looking for. So how do I write up that complement? And that's what I was saying. Here's our number of, we do the Pn binomial, where my number of, so we're going to go from 4 or less. So it would have to be 4, 6, 0.25. And this is that probability in there. So we do that in R binomial. And now we put in the 4, the 6, and the 0.25. Enter. And that would be what the probability of that complement is. So x10, if I wanted to find it, the actual complement, I would do 1 minus x9. And we would say, if I wanted to round, 0.9803. And that's using the negative binomial. So hopefully this was helpful. Thanks for watching. Bye.